By the way, you're not having to write these. I posted a copy of these on eClass already, but we are going to talk about it in a second. Tomorrow is a digital day, which means that you guys need to make sure that you are actually completing the stuff, but I will not be available via Zoom, okay? You can send me messages on Remind or text me and I will be available, but I will not be available via Zoom because tomorrow is a digital day, okay? So all my friends in here, my 3 of you, y'all will be at home, okay? All right, so we're gonna quickly go through these notes right here. I already put a copy of these notes on eClass, so you don't have to worry about writing them down, but I do want you to listen because there are like 3 questions on your test about the difference between solvation versus dissociation. So this is the first thing we're going to talk about, and then we're going to talk about molarity and how to calculate molarity. It's pretty easy, which is good news. Simple division, not quite as complicated as what we've done before, okay? So when we dissolve something, this is solvation versus dissociation. When we dissolve something, obviously most of the time it disappears and you can stir it or shake it or increase the temperature, things like that. However, if we were to use a microscope and look at what is actually happening when we dissolve something, there's kind of 2 different processes that happen here, okay? So the first one is called solvation, and this is what solvation is. It is the solute particles are separated and surrounded by the solvent. So solute is what you're dissolving. Solvent is what is doing the dissolving. So for example, if I have Kool-Aid, my solute is the powder and my solvent is water. Water is dissolving the powder, okay? Now, solvation looks like this. If this red little structure right here, if this is Kool-Aid powder and the blue circles are water, water will surround the little particles, and that's how it dissolves. It's like taking like chips off of an ice block, right? Like if you take a knife and you got a big block of ice and you kind of chip it away, chip it away, chip it away. So it's taking each little molecule and it's separating it from the rest and then carrying it around in the water. So solvation is where it's just separating and surrounding the solute particles, okay? So that's the first part. Let me show you. Let me show you. So this guy right here, and I'm going to use a color. This guy right here is Na. That is sodium, okay? The one in the middle. Each one of these guys out here, that's water. So what's happening here is that the water will surround whatever the particle is, like the solute, whatever you're dissolving, okay? So that's what solvation is, just where the water, usually water, surrounds the molecules and kind of carry them away. Now, the next one is called dissociation. Solvation happens all the time for everything. Dissociation does not happen for everything, okay? So here's what dissociation is. When ionic bonds, that's semester 1 stuff. Ionic bonds are bonds between metals and nonmetals. When ionic bonds go through solvation, where the water particles are surrounding them, what they do is they undergo dissociation, which means that the particles break down into ions. Ions are just positive and negative parts, okay? So this is a picture I drew for your notes, but I'm actually going to show you a different one. So here's this picture right here. This is a block of a bunch of different salt molecules, okay? The big ones are like, this is like Cl, and this is Na. So NaCl, that's salt. We got a lot of salt particles here, right? Dissociation, instead of carrying away the Na and Cl together, it separates it into Na and Cl. And the thing I want you to notice here is that there's a plus sign right there and a minus sign right there. Anytime that you see like plus signs and minus signs, and when it's talking about ions, your immediate thought needs to go to dissociation, okay? Dissociation, you see all these negative signs right here, and there's a positive sign there. Down here, we got a negative sign here, but there's a bunch of little positive signs right here. This is dissociation. So if this was just solvation, it would look something closer like this. Here's Na, here's Cl, and then the water molecules would be doing this number right here. All of the water would be around the whole thing. Water molecules look like Mickey Mouse ears, by the way. So this right here, if it was surrounding both of them, is just solvation. But because NaCl is an ionic compound, instead what happens is it gets separated into its parts, Na and Cl. Ions. Okay, ions. Positive and negative. So here's the deal about the notes. The notes are there on eClass for you. Today you're going to have your like homework. We may not get to it in class, but it is your homework. And I will also make it, it's not going to be due until tomorrow, because tomorrow is a digital day. But there is a mini quiz. It's 5 questions. Obviously you get to use your notes, things like that. And there is a question about what the definition of solvation is. If you get that question wrong, I'm gonna judge you just a little bit, and here's why. The notes on eClass have the word for word definition that's on the quiz right here. So if you don't use your notes, there's nothing I can do for you, right? Because I'm giving you this stuff right here. Y'all gotta use your stuff. So that's solvation versus dissociation. I would not like worry too much about like knowing all the concrete details and everything like that. We're going to practice some of this later, especially before our test, but you only have like 1 or 2 questions on your test about this. Okay. But I did need to tell you the difference. So we're going to move on. Okay. I know that was super quick. And I know that you're like, I really don't understand the difference. It's okay. We're going to talk about it again at some point, but we need to get through molarity today. So here's what I need you guys to do. On eClass, under the second column, yes, it says molarity. Oh, here, let me just show you. Under the second column, molarity notes and practice, right here. Go ahead and open up that document for me, please. It's a Google slide. Oh no, I got the hiccups. Okay, so go ahead and open up that document for me. And this is what it looks like. Whenever it decides it wants to. There we go. Come on, come on, come on, come on. You can put your name there if you want, but don't feel like you have to, because it shows me, it assigns your name on it anyways, okay? So today we're gonna be doing just a little bit of math. It's really not crazy, I promise. It's really super not bad. Okay, so you need to follow along with me and be filling out the stuff on this PowerPoint as I go. And as we go through this, so that you have this, because this is gonna act as your notes for molarity, okay? And you're gonna need that not only for your quiz, but for your practice tomorrow, because remember, tomorrow's a digital day, okay? So this is a warm-up. I'm gonna actually show you something. You are not gonna do this warm-up thing right now, okay? I'm gonna show you something. It's a little life hack. Now that we are out of unit 2 and out of unit 1 about stoichiometry and all that stuff, I'm about to show you a little life hack if you haven't figured it out already. Okay, there's a website, by the way, that if you need, if you type in molar mass calculator into Google, there's a website from a company called Lentech, Lentech, Lentech. Okay, and it says molar weight calculator. If you click on this, I'm about to change some of your lives. Okay, I couldn't really share this with you during the last unit because, you know, like you were supposed to know how to do it on your own. But let's say that you want to know what the molar mass of some really big compound is, like sugar, C6H12O6. That's a lot of math. What you can do instead is capital C, 6, H12O6, right there. in the formula, and then you press calculate. Oh my goodness, look at that. It even breaks it down for you. And it tells you what the total is. My suggestion is moving forward, whenever you need to calculate molar mass, don't spend your time doing that, okay? There's a molar mass calculator out there that can do it for you, now that you know how to do it. Now, you can't necessarily use these on like big tests. Well, for tests for my class, you can, but if there's like they're not going to do a district final, but if they did, you wouldn't be able to use that, okay? So that's something to keep in mind. So like the on the PowerPoint, when it says like, what's the molar mass of, this is Mg3PO42. We are going to fill that part in, okay? Watch this. Mg3PO42. Just like that. And that's a big number. It's a big number. So on your slide, if you'll just go ahead and put 262.8, yeah, 262.8 right here. Okay, 262.8. And then that way it's there in case you need it. All right. This is a moles to grams, or sorry, grams to moles. This is stuff we did in Unit 1, the very beginning of the semester. We're not going to spend time going over that right now. What we are going to talk about is this next slide right here called concentration. So concentration tells us about how much solute or how much stuff we're putting inside of our solution. So if you want to make sweet tea, the concentration might be how much sugar did you put in, right? That's what's dissolving in the sweet tea. So more concentrated means more sugar. Less concentrated or diluted means there's less sugar for sweet tea. Sometimes you have to dilute stuff. Y'all know Campbell's soup in a can. They call it condensed soup. So what you're supposed to do, and I spent a long time in my life not knowing that this was a thing, you're supposed to pour the can of like Campbell's regular tomato soup, like the little ones, into a bowl, and then you're supposed to add a can of water. I had no idea. It took me a long time to know that. So if you didn't know that, now you know. Okay, but when you do that, you are diluting the soup by adding water. You're lessening the concentration, okay? That's what concentration is. Now, here's what molarity is. We've talked about moles. We've talked about how to find moles and all that stuff. Molarity is what the concentration is of a solution using moles per liter. So it says molarity is the number of moles of solute per liter of solution. So if we made 2 liters of sweet tea, y'all know what a 2 liter looks like, a 2 liter bottle. If we made 2 liters of sweet tea, then down here on the bottom, it would be 2 liters. And if we put 3 moles of sugar, it would be 3 moles on the top, 3 moles over 2 liters, okay? So that's all we have to do with this is moles per liter. The tricky part comes in is when they give you like milliliters instead of liters, or they give you grams instead of moles. That's where things get not complicated, but just a little bit more involved, okay? So let's look at the next slide. We're on slide number 5, right? So it says there are 3 moles of AuCl3 dissolved in 1 liter of solution. What is the molarity? The formula for molarity is moles of solute on the top divided by liters of solution. So for this one, 3 moles divided by 1 liter. Okay, 3 divided by 1 equals 3. Now, if you notice, let me back up one slide. If you notice in parentheses and or brackets, they gave you the abbreviation for the unit. So you guys know MOL is moles. A capital L is liters. And then here's the thing with molarity. Molarity is a capital M. It must be a capital M because a lowercase m means something completely different. Okay, so it must be a capital M. So on the second problem on slide number 5, it says there are 3 moles of NiCl2 dissolved in 2 liters of solution. What is the molarity? So here's what we're going to do. It's moles per liter. So moles divided by liters. So all you have to do for this one is fill it in. So what goes in the first box? If it's moles per liter, Yeah, 3 moles, right? And you can type moles if you want. 3 moles. Okay, now here, we're gonna just put the little division symbol, which is a slash. Doesn't matter which one, forward or backward, whatever. And then how many liters does it tell us that we have in the problem? 2. So 2 liters. 2. Oh, and then, oh, but I did not mean to do that slash. So 3 moles divided by 2 liters. So use your phone or a calculator, whatever's handy, and do 3 divided by 2. Zoom, tell me in the chat. Wonderful. What'd you guys get? Okay, so I got an answer from here, and I got an answer, several answers from Zoom, which I'm very impressed by, because one person told me not just 1.5, which is true, they also put a capital M. So make sure you put a capital M. That means it is 1.5 molar solution. 1.5 molar solution. That's the molarity, is 1.5 moles per liter. All right, the next one, not so bad. There are 3 moles of CONO32 dissolved in 0.5 liters of solution. What is the molarity? You guys try this one on your own. Fill in the blanks. Give me an answer in the chat for you guys. Good job, you, Malik. Good, good. What'd you guys get? Yes. So it should be 3 moles divided by 0.5 liters equals 6. And then what comes after the 6? What kind of M? A capital M. Good job. Okay, just like that. So those are our basic molarity problems. I told you, it's really not so bad. It's really, really not so bad. Okay. Now, like I said, sometimes things get a little weird, but only sometimes. So let's move on to slide number 6. Let me show you what's going on here. So in this problem, what's happening is they are actually giving us like a different thing. Instead of asking us to find molarity, they're giving us the molarity and asking us to find something else. So for the purple one, it says solving for moles of solute. So if it says how many moles of salt are in 3 liters of a 2 molar solution. So we talked about this triangle guy right here when we talked about density during semester 1. So I know it's been a while. But here's how this works, okay? You cover up whatever unit that you're solving for. So if it says how many moles, we're going to cover up moles of solute. So when we do that, all we have left is molarity and liters of solution. And this sign that's right there, you'll have to look closely on your screen, is a multiplication symbol. So it actually tells you how to do the math, okay? So in this case, we're going to do molarity, whatever the molarity is, the capital M. We're going to multiply it by liters of solution. So here, we're going to do the molarity first. So it says how many moles of salt are in 3 liters of a 2 molar solution? So first one, 2 capital M. Okay, should be typing it as I'm typing. 2 capital M. And then our little triangle here over here tells us that we're going to be multiplying. So in our box right here, we're going to multiply. And then we're going to multiply it by how many of our liters of solution we have. And it tells us we have 3 liters of solution. So what's 3 times 2? 6. So our answer is 6 moles. So it's the same type of math. We're just solving for something different. Okay. Let's look at the red one. Let's look at the red one. So this one says that we're going to be solving for liters. So for solving for liters, and you can use this thing off to the side. This is off to the side over here. You can use this to help you if you'd like. So for solving for liters, we'll put our little box over here and cover that up. And now what does it tell us to do? We've got moles of solute divided by molarity. Okay? Moles of solute divided by molarity. So the problem says you have 2 moles of salt. How many liters of solution do you need to make the molarity 1.5 molar? Okay. So we're just going to follow what the triangle tells us to do. Moles of solute divided by molarity. So 2 moles of solute. Okay. Then we're going to divide by, and then we're going to divide by our molarity, which is 1.5 molar. Okay. Do that on your calculator. Zoom, tell me in the chat. You're doing 2 divided by 1.5. What'd you get? Good, Lucas. I'm like, I'm not sure. I think you did your math backwards. Yeah, there you go. Nice. Nice, nice, nice. Okay. And this one we're solving for liters. So when we type in our answer, which you guys told me, where did my mouse go? There we go. So it's 1.3, and instead of capital M, we're going to do a capital L per liters. That's what we're trying to find. All right. What kind of questions can I answer so far? Do I have any questions so far? No? The L will also be capitalized, yeah. Yeah. All right, in that case, if I don't have any questions, here's what I want you to do. I want you to try slide number 7 all by yourself, okay? And Zoom, what I want you to do is I want you to wait until you're done with all 3 and send all 3 answers at the same time, okay? So you can call them 1, 2, and 3, or you can call them A, B, and C. Doesn't matter, okay? But each one, look, each one you're going to be solving for something different. So how many moles? If you're finding moles, then cover up the unit you're looking for. So for the first one, we're going to be doing this times this. How many liters? We'll cover up liters. Come on. And then we have moles divided by molarity. And then how many moles? Okay. I want you to try that. Everybody. Everybody. Okay. I haven't put up the answers yet, but check your work to make sure that the work is correct. Okay. If your work is correct, then your answer should be correct as well. Good. Knowledge, good job. Okay, so the first one, I've had a couple of people tell me already. What's the first one? What's 6 times 1/2? Make sure your units are correct. So your answer for the first one should be 3 moles, MOL. Okay. Your answer for the second one. It does matter if the numbers are switched, and here's why. 12 divided by 3 is a lot different than 3 divided by 12. Okay, 12 divided by 3 is 4. That's not the answer to this question. Okay, so you need to make sure you're doing exactly what the formula is telling you to do with this little thing over here. So for this one, it says how many liters. So if we're looking for liters, we can actually cover it up. Okay, and it's going to tell us moles of solute divided by molarity. So the moles that it gives us is 3 moles. So that goes first. Then divided by, and then it says divide by molarity. So then right here, 12 molar, or capital M, goes second. So 3 divided, yes, it does matter what order they go in. Okay, except for the multiplication ones. That one doesn't really matter. So this one should be 0.25. Oh, I'm not typing. Okay. And then this one is 6 moles. How are we feeling about this? Pretty okay? How are we feeling about it? On a scale from 1 to 3, 1 being I have no idea what you're talking about. 2 is I kind of get it, but I still need some help. And 3 is like, I got it. This is easy. Okay. What do you think? 2, 2, 3, 2, 3, 1, 2, 3, something like that. Okay. Because if you really don't understand, I need to know, because what we're going to do in just a second is a little bit more involved, meaning it's going to require a little bit more effort for this one. Okay. Okay, so if you guys are ready to move on, let's take a look at the next slide. And this is probably, after we do this, we'll end for today. Okay. So it says, what if you knew the grams of solute and it asks you to solve for molarity? So what this means is they don't give you the moles, but they give you grams. This is where you're going to have to do a little bit of stoichiometry. Okay. And I know it sucks, but it is what it is. So here's what you're going to do. Remember that website I told you about? It says step 1. We're going to convert the grams to moles by dividing the molar mass. You guys have done this. Okay, you've done this. So here's what we're going to do. It gave us, so the molar mass of NaCl, I'm going to show you right now. NaCl. The molar mass of NaCl is 58.44. So in the box on slide number 8, right here, this green box, 58.44. Okay, grams. That's the molar mass. So what we're going to do is we're going to start by giving what the problem gave us, which is 100 grams of NaCl. Right, 100 grams of NaCl. So in the first box, we're going to do 100 grams NaCl. That's what goes there. On the bottom, if grams of NaCl is up here, grams of NaCl has to be on the bottom. So we're going to do our molar mass, which we said was 58.44 grams of NaCl. And then up here on the top, we're going to do 1 mole. So we got to go from grams to moles first. That's the part that gets complicated. Okay, but you've done it before, so not too bad. So if we are looking, use your calculator, do 100 divided by 58.44. Everybody right now. 100 divided by 58.44. Okay. And you should have gotten like 1.7 moles of NaCl. Okay. That's what, I'm gonna do real quick. A little bit better. Maybe a little bit better. Yes. Okay, there we go. No. So that's the first step. We went from grams to moles, and now we can find the molarity. So remember, molarity is moles divided by liters. And here's where we are. Okay. So moles divided by liters. So the moles we calculated in step 1. So in this first box right here, we're going to put 1.7 moles of NaCl. Well, we can just put 1.7 moles. Okay. Moles divided by liters. Well, it tells us in the problem 100 grams of NaCl are dissolved in 2 liters. So right there, it's going to be 2 capital L liters. So in your calculator, please and thank you, please and thank you, do 1.7 divided by 2. So in this box here, 1.7 divided by 2, you should have gotten 0.85 capital M. Okay, 1.5, or sorry, 0.85 capital M. Okay. How are we feeling about this? Pretty okay? Yeah. Zoom, how do y'all feel about it?